This is the second day of section 7.4. Today we're going to talk about the properties of the rhombus and the square. So a rhombus has all of the same properties of a parallelogram. So the opposite sides are congruent, the opposite sides are parallel, opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other. Now we have some additional things. Just like the rectangle had some additional properties, so does the rhombus. So by definition, all sides are congruent. That is what defines a rhombus. It is a parallelogram where all sides are congruent. But in addition to that, now we also have the fact that the diagonals bisect the opposite angles. So they cut the angles across from each other in half. And the diagonals are actually perpendicular to each other. So when they intersect, they form right angles. So for our first example, we know we can mark all the things that we know about a rhombus. We know that all four sides are congruent. And we know that right angles are formed and opposite angles are bisected, but we're not dealing with any angles here. I'm not even going to put that in. So we know JK is 12, which means every single side is 12. And we know JN is 7, and the diagonals still bisect each other, but they're not congruent to each other like they were in a rectangle. So JM is 12. JL is the 7 and 7 together, that's 14. MN, now here's one we don't know, but if I created a right triangle with my right angle, then I know that I have something 7 and 12, and 12 is my hypotenuse, so that's the C value. So we would have x squared plus 7 squared equals 12 squared for our Pythagorean theorem. So if I subtract 144 minus 49, we get 95. And if I take the square root of it, I get 9.7 about. So that means MN is 9.7, and MK, which is now 9.7 and another 9.7, we would have 19.4. You go ahead, try this problem, pause. When you're ready to see the answer, hit play. All right, so we get 23 for all the sides. HF is 20 because it's the same as the other part of the diagonal. I did the Pythagorean theorem to find GH, and I got 11.4, and then doubling that for GE, I got 22.8. All right, the next one, we're going to deal with the angles, and let's actually get a better view of this. Okay. So we know that the angles that we and they're the same as those. Four of these are 38 degrees. We also know the diagonals are perpendicular. And these are right angles, so that makes it 90. And we know, because it's parallelogram, the consecutive angles are supplementary. So together, these triangles, 38 and 38, were 76 degrees. That means together, these angles should be 180 minus 76, or 104 degrees. And because these angles got bisected, each one is half of 104, or 52 degrees. And now that I have all of that filled in, I should be able to answer all these questions. So angle 1 was 52 degrees. Angle 2 was 52 degrees. Angle 3 was 38 degrees. Angle 4 was 38 degrees. Angle 5 was 38 degrees. Angle 6 was 52 degrees. Angle 7 was 52 degrees. And angle 8 was our right angle. That was 90 degrees. All right, so you're going to try this next one. Pause. When you're ready to see the answer, hit play. All right, so knowing both of them were 61 makes both of those 61, a total of 122. Take that away from 180 to find the entire angle down here, the consecutive angles, 58, and then cut that in half for 29. So angle 1 was 90 degrees, angles 2 and 3 were both 61 degrees, and angle 4 was 29 degrees. All right, so in this next one, it tells me that it's a rhombus, and I want to find the length of MP. And because subtract 3x, that's 77, so we get 6x equals 84. Divided by both sides by 6, I get x equals 14. So MP, anything equal to either of these, this seems easier to plug in. So I'm going to take 3 times 14 plus 7. So we get 42 plus 7. So that means MP equals 49. So you can go ahead and try the next one. Find PQ, pause, and when you're ready to see the answer, hit play. All right, setting them equal, we get x is 12, and because we're looking for PQ, I could plug it into either. It was easier for 5x plus 16, so PQ is 76. All right, so again, we have angles and angles, sides by sides, and these angles are equal to each other. Subtract 5x and 3, we divide, and we get x is 7. We're looking for angle FED, this whole angle here. So if I know this whole angle here, and take it away from an 80, that'll give me this whole angle here. So let's put 7 in. So 5 times 7 plus 1, 35 plus 36, and 36. Meaning this whole angle is 72 degrees. So 180 minus 72. So you could say that the measured angle FED is 108 degrees. I'm actually going to jump to the try, and then we'll go back to the example for you to do. So here, so what I did is I took the fact that this is alternate into this. Let me check. So I took that angle plus that angle. Oh, okay. I didn't actually use the alternate. Let's go back. So I know that this is 90, so I use this triangle. So if this triangle is 180, and I know 7 plus 90 equals 180, I solve this. So that's 11x. Negative 1 plus 3 plus 2 plus 90 is plus 92. Subtract the 92. And then divide by 11. So we got x is 8. I'm looking for HDI. So this angle here is what I was looking for, and that should match the 4x plus 3. So we plug in 8, 4x plus 3, 32 plus 3 is 35. So the measured angle HDI is 35 degrees. All right, now you are actually going to try this example. We're looking for the measure of angle ADB, so this angle over here. So you can pause, and when you're ready to see the answer, hit play. All right, so since the angle got bisected, we set the 9x plus 4 equal to the 13x minus 16, and when we solve, we get x is 5. When I plug 5 back in, 9 times 5 is 45, plus 4 is 49, so each of these angles are 49. Together, 49 and 49 is 98. Consecutive angles are supplementary, so 180 minus 98 was 82. And then I cut the 82 in half, so each one was 41. So the measure of angle ADB was 41 degrees. So that's all rhombuses, and now we're going to talk about the square. So the square actually has every property of both a parallel, not both, of a parallelogram, a rectangle, and a rhombus, because it is actually the intersection of the rectangle and the rhombus. So all of these were properties of a parallelogram. Then, because it's like a rectangle, it has four right angles, and its diagonals are congruent. And because it's like a rhombus, it has four congruent sides, the diagonals are perpendicular, and it bisects the opposite angles. So in our picture, so BC, AC has something else. So I have a big triangle here. The two sides are 11 and x is my hypotenuse. So we're going to use Pythagorean theorem. So that's 36x squared. That's 121 plus 121 equals x squared, 242. And now we'll take the square root of both sides. So we get about 15.6. So AC, the whole diagonal, is 15.6. So BD, because the diagonals are congruent, is also 15.6. EC is going to be half of the length of the diagonal, or 7.8, right? Because the diagonals are bisected and congruent to each other. So then it takes us to the angles. We're actually going to get rid of a lot of these markings because it's going to get in the way. So we do know we have right angles in every corner, and we know we have right angles where the diagonals intersect. Measure of angle DAB, that is 90 degrees. Angle AEB is also 90 degrees. Angle CBD, so that's this portion of the angle. And because it got bisected, each of these halves is half of 90, or 45 degrees. So then angle BAC is also 45 degrees. So those angles will never change if it's a square. It's always going to be 90s and 45s, and that's it. So you go ahead and try this one. Pause when you're ready to see the answer. Hit play. All right, so TR in this case was a part of the diagonal, so that was 17. Every other part of the diagonal 17, meaning whole diagonals were 34. We did Pythagorean theorem using the two 17s to find a side. We got about 24.0 for the length of the side. And then, like I said before, our angles are either 45 or 90. 45 if it's one of the little guys here, 90 if they're talking about the whole thing or where the diagonals intersect. All right, so our next example, they're telling me FT and FT. So those are equal. So we get 3x equals 21 again, x equals 7. And I'm looking for SU. Ooh, so this is here. So SU is going to make our right triangle. So we're going to plug in x to the side, find out how long they are. So 6 times 7 is 42, 7 is 49. So now we're going to do Pythagorean theorem. So we have 49 squared plus 49 squared equals x squared. 49 squared is 2401. So together that's 4802. And then we could take the square root. So we get about 69.3 for the length of x. All right. Go ahead, try the next one. Pause when you're ready to see the answer, hit play. All right, so they gave us SW and WU, two parts of the diagonal. So we set them equal, we get X is 9. They were looking for VT, which was the entire diagonal. So if I put 9 back in, I get 31 for each of these individual pieces. So together, TV was 62. All right, so for the last kind of problems for our square, we know if I had 4 parts, I would either so now I can subtract 3, divide by 7, and I get X is 6. So try this last one. You are given the fact that angle SWV, this one right here, is 4x minus 10. Solve for x. Pause. When you're ready to see the answer, hit play. All right, because that angle represents a 90-degree angle, we set 4x minus 10 equal to 90 and solve and get x is 25. And that is the second day of 7.4 for the rhombus and the square.